the representation of Fourier series in polar form. We have derived the real Fourier series, which is the trigonometric Fourier series, x of t, which is a periodic signal with a period t, which is 2 pi by omega naught. Then I can represent any signal x of t as a naught sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught. Now I will write this as a naught n to infinity an cos n omega naught t plus bn sin n omega naught t. A naught plus sigma n equal to 1 to infinity. What do I do? Square root an square plus bn square. I will divide and multiply an by square root an square plus bn square cos n omega naught t plus bn, right? I will divide and multiply with square root an square bn square. Now this term an by square root an square plus bn square, this term as cos pi, right? If it is cos pi, then it will become sin pi. Right? Okay. So this is the triangle. This is pi. So this cos pi is an by square root an square plus bn square. So I will take an as adjacent side, then square root an square plus bn square as hypotenuse. Then this opposite side will become bn, right? Just square root an square plus bn square minus an square from the Pythagoras theorem. An square gets cancelled. Square root bn square is bn. That's it. Now from this, what is sin pi? Opposite side by square root an square plus bn square. Right? Now what is tan pi? Tan pi is bn pi an. So this term as cos pi and this term as sin pi. Replace these two terms by cos pi and sin pi. Now xt equal to a0 plus sigma n equal to 1 to infinity square root an square plus bn square and cos pi cos n omega naught t plus sin pi sin n omega naught. Now I will replace this as some Rn, right? Now this is this n omega naught is a, this pi is b. So this a, this pi is b. Cos a cos b plus sin a sin b. Cos a minus b, that equal to a naught plus sigma n equal to 1 to infinity Rn cos a minus b, right? Now I will replace this a naught by r naught, right? This just replace by a naught by r naught. Okay, this a naught equal to r naught. Now r naught plus sigma n equal to 1 to infinity Rn cos n omega naught t minus pi. Now this R naught, I will bring this into the summation. Sigma n equal to 0 to infinity or in cos n omega naught t minus pi. That's it. Now where Rn is square root an square plus bn square and R naught is a naught and pi is tan inverse bn by an. And this is representation of Fourier series in polar form. So x of t is periodic with period capital T that equal to 2 pi by omega naught can be written as sigma n equal to 0 to infinity or n cos n omega naught t minus pi. Rn is square root an square plus bn square and pi is tan inverse bn by an. Now we have already derived this an. An is 2 by t and here r0 equal to a0, r naught equal to a naught. 2 by t integral of 0 to t x of t cos n omega naught t. Now I will substitute n by minus n. I'm just checking what it will become. A minus n. I will replace n by minus n. 2 by t integral 0 to t x of t cos minus n omega naught t. Cos minus theta will get cos theta. 2 by t integral 0 to t x of t cos n omega naught t. So an is even, right? Here we got a minus n is an. That is an is even. Similarly, I will check bn. So what is bn? We already derived 2 by t integral 0 to t x of t sin n omega naught dt. Replace n by minus n. T minus n 2 by t integral 0 to t xt sin minus n omega naught t dt. Sin minus theta is minus sin theta. I'll put this minus sign outside. Minus 2 by t integral 0 to t xt sin minus n sin n omega naught t dt, which is minus bn, right? So b minus n equal to minus bn. So bn is odd. Right? I'll check what about Rn. So Rn is square root an square plus bn square. What is r minus n? A minus n square plus b minus n square. Here you get a minus n is an and b minus n is minus bn, but we are squaring here. That is an square plus bn square. So that is Rn, right? R minus n is Rn. That is Rn is even, right? Next I will check pi n. Pi is, or you can write it as pi n, function of n. This tan inverse bn by an. Pi minus n tan inverse b minus n by a minus n. Here minus bn by an minus tan inverse bn by an, that is minus pi n. So pi minus n is minus pi n. So pi n is odd. Okay. In polar form, this Rn is even, this pi n is odd.